I'm going to run back through perfect cubes again because I have a student in 5th period who didn't get a chance to see any of this yesterday. So I'm going to run back through perfect cubes, how to get one, and then we'll go on and talk about negative perfect cubes and inverses. How many times do you multiply a number, and it should say by itself, to get a perfect square? You just think about square. The exponent 2 is for squaring. But to get a perfect square, you multiply a number by itself twice or 2 times. For instance, you could say 5 times 5, which is 25, or just square 5, and you'll still get a perfect square of 25. Or 7 times 7, 7 times 7 produces a perfect square of 49. Or you could just square 7 and also get a perfect square of 49. Well, if you multiply a number by itself 2 times to get a perfect square, the next question becomes, how many times do we multiply a number by itself to get a perfect cube? And that would be 3 times, guys. So now we're going to move from talking about perfect squares to perfect cubes. So instead of 5 times 5, which produces a perfect square, I'm going to do 5 times 5 times 5, 3 times. And it's going to produce a perfect cube. 125 is known as a perfect cube. But just as I can rewrite 5 times 5 as 5 squared, I can rewrite 5 times 5 times 5 as 5. And we read this as cube. 5 cubed. It just means you're multiplying 5 by itself 3 times. 5 times 5 times 5. And it produces 125. Or 7 times 7 times 7. Well, 7 times 7 is 49. And 49 times 7 is 343. But just as I write 7 times 7 as 7 squared, I can write 7 times 7 times 7 as 7 cubed because I'm using 3 of those. All right, so if you take a look here, it says positive cubes and positive cube roots. Right now, and just in that chart, we want to list some positive cubes. So we're going to think about the smallest whole number cube that exists, and that will be 1. Because you get that from 1 cubed, which is 1 times 1 times 1. The next smallest whole number cube would be 8. You achieve that from 2 cubed, or 2 times 2 times 2. 2 times 2 is 4, and 4 times 2 is 8, of course. The next smallest cube, whole number cube, would be 27. And that is achieved from 3 cubed, which is 3 times 3 times 3. 3 times 3 is 9, and 9 times 3 is 27. If you haven't done so, you're going to pause the video and fill out the rest of this table and find the remaining perfect cubes that will fit in the table. We're only going to do the first 15 of them, okay? Pause the video and let's find the remaining perfect cubes. All right, this is what you should have. 4 cubed produces 64. 5 cubed produces the perfect cube, 125. 6 cubed produces the perfect cube, 216. 7 cubed produces the perfect cube, 343. 8 cubed produces the perfect cube, 512. 9 cubed produces the perfect cube, 729. 10 cubed produces the perfect cube, 1000. 11 cubed produces the perfect cube. I don't like writing that right there. Hold on. 11 cubed produces the perfect cube, 1331. 12 cubed produces the perfect cube, 1728. 13 cubed produces the perfect cube, 2197. 14 cubed produces the perfect cube, 2744. And 15 cubed produces the perfect cube, 3344. 375. So those are the first 15 perfect cubes you should have listed in your notes. And notice I bubbled in positive. That's because you do have a set of negative perfect cubes, guys. But I want to go back to perfect squares for just a second. These were our perfect squares. You don't have to list them. I'm just going to show you this. You don't have to write this down. And so forth, okay? But if you'll notice, none of my perfect squares were negative. But I specifically said here positive. That's because if you can have positive perfect cubes, and you can also have negative perfect cubes, guys. Whereas with squares, you can only have positive squares, because anytime you multiply a number by itself, or you use that number twice in a product, and only itself, like -4 times -4, 4 times 4, you'll only be able to get a positive. You'll never be able to get a negative when you multiply a number times itself. But with a cube, you can multiply a number by itself 3 times and get a negative. And we're going to talk about that on the back page. Okay, before I go to A, B, and C, let's talk about inverses. Inverses are operations that undo each other, and you learned some. Some of these you learn in elementary school, like addition undoes subtraction, or kind of like it's the opposite of subtraction. Multiplication is the opposite of division or inverse of division, or subtraction is, so I could say addition is the inverse of subtraction, subtraction is the inverse of addition, the inverses of each other. Multiplication is the inverse of division, but yet division is also the inverse of multiplication. And then you learned last week squaring. Squaring is when you multiply a number by itself, like 5 times 5, or 5 squared, keyword squaring, squared. The inverse of squaring is square rooting. So 5 squared produces the perfect square 25. 25 is a square, guys. It is the square of 5. So 25 is the square of 5. 25 is a square. To undo a square, you learn to take the square root. Okay. So the inverse of the square, I'm going to put it in red. That's a square. To undo a square, you take the square root, and 25 is a square, guys. It is 5 squared. But to undo a square root, you could square it. This little 2 would undo the square root, and it would put us back at 25, okay? But to undo this square, which is 5, 25 is 5 squared, take the square root, okay? And it puts us back at 5. I'm going to talk about one more inverse today, okay? So I'm going to erase this. I don't have enough room. And that inverse, I'm going to make this a little shorter. I still want addition and subtraction. I'm just going to write it where it's not as large. Sorry about that, guys. We said squaring and square rooting. And there's one more you're going to learn today. And that will be cubing, from the word cube. Cubing and instead of square rooting, cubing, and what we call cube rooting. Okay. So a square, again, is when you square a number and get something like a perfect square. A square root looks like this, okay? A cube, everybody knows, is when you maybe cube a number, or you multiply by itself 3 times and you get a perfect cube. But cube rooting, you don't know what it looks like, so I'm going to give you the notation for cube rooting. It kind of looks like the square root symbol, but it has a little 3 in it. So that's how we know the difference between a square root and a cube root. A cube root will have 3 in what we call like the index mark or position. Right here on the inside of this, it'll have a 3. So if I wanted to take the cube root of the perfect cube 125, 125 is a cube. To undo a cube, we cube root. So you just think to yourself, what number did we multiply by itself 3 times? 3 times to get 125. And we look up here and we see that you multiply 5 by itself 3 times to get 125. So the cube root of 125 is 5. So when I get ready to go over A, B, and C, I want to use the appropriate notation, guys. So it says, what number times itself 3 times is 27? In other words, what number did I cube to get a 27? So 27 is a perfect cube. And I know you all know it's 3, but we're going to use mathematical notation. So if you want to figure out what number you multiply by itself 3 times to get a perfect cube of 27, you're going to do the inverse of cubing, because 27 is a perfect cube. The inverse of cubing is cube rooting. So I'm going to, in mathematical notation, I'm going to put the cube root of 27 is 3, because I multiplied 3 by itself 3 times to get a 3. All right, B says, what number did I multiply by itself 3 times to get 343? Well, this also is a perfect cube. And to undo a cube, we cube root. So to work backwards to figure out what that is, I write it in that notation. The cube root of 343 is 7. What number did I multiply by itself 3 times to get 8? So you're going to pause the video and do that. Write it in mathematical notation, the correct notation, okay? All right, this is what you should have. You should have the cube root of 8 is 2, because we multiply 2 by itself 3 times to get an 8. All right, so you should understand positive cubes and positive cube roots. If you have a positive cube, the cube root will also be positive. I just use cube root notation. But that doesn't hold true for square roots. If you take the square root of 16, the answer can be positive or negative, guys, okay? So square roots can be both positive and negative. But the cube root of a positive cube is also positive. It's not positive or negative. So we won't be using plus or minus in front of these cube roots, okay? Just a little note. All right, now we're going to talk about negative cubes and their cube roots. So I'm going to start off, instead of 1 cubed, with negative 1 cubed. So you can use the even odd rule, or we can actually work this out based off the rules that we know from multiplication. You could say that there are 3 negatives. 3 is an odd number, and an odd number of negatives will equal to a negative answer. Or you could say, you could take negative 1 and multiply by negative 1. A negative times a negative is a positive 1. And 1 times negative 1 is negative 1. Okay. I'm going to stick to the fact that I have an odd number of negatives because I have 3 negatives. So I know my answer is always going to be negative. So negative 1 cubed is simply negative 1 times negative 1 times negative 1, which is negative 1. Negative 2 cubed is negative 8 because you still have 3 negatives. Negative 2 times negative 2 times negative 2. You still got 3 negatives. Matter of fact, in all of these cases, you're going to have 3 negatives and 3's odd. So your answer is always going to be negative on these. When you cube a negative number, you're going to get a negative answer. Y'all, hold on. Hello? I'm on video. Sorry about that, guys. All right, so, and then here, the next one, we're negative 3 cubed, which is negative 27. I'm sure you've already filled this chart out. And if you have, that's good. I'm going to go ahead and quickly list these. I apologize for having to step out. Negative 5 cubed is negative 125. Negative 6 cubed is negative 216. Negative 7 cubed is negative 343. Negative 8 cubed is negative 512. Negative 9 cubed is negative 729. Negative 10 cubed is negative 1,000. Negative 11 cubed is negative 1,728. No, that's not. Negative 1,331. Negative 12 cubed, I'm just going to look back over here, is negative 1,728. Negative 13 cubed, let me write that a little better. And if you didn't write these down and I'm going too fast, just pause the video. That's all you got to do. Negative 13 cubed is negative 2,197. Negative 14 cubed is negative 2,744. And negative 15 cubed is negative 3,375. So whereas you don't have negative perfect squares, you do have negative perfect cubes. Perfect squares and perfect cubes are like opposites of one another. You can have two answers for the roots of perfect squares if you take the square root of a perfect square, but you can only have one answer if you take the cube root of a perfect cube. And then perfect squares can only be positive, and perfect cubes can be positive or negative. All right, A says what number times itself is negative 27? I'm going to use cube root notation. Negative 27 is a perfect cube. It's just a negative perfect cube, but nevertheless, it's still a perfect cube. Well, the cube root of negative 27 is negative 3. What number times itself is negative 343? With the cube root of negative 343 is negative 7. What number times itself is 3 times is negative 8. The cube root of negative 8 is simply negative 2. So what I'm trying to get you to see is cube roots can only be positive or negative. They cannot be both. I'm just going to put it cannot be both. So you would never use plus minus on cube root. Never, ever, ever. Don't do that. Only use plus minus on square root, okay? All right, so it says for A, B, and C, we're using the inverse of cubing, which is taking the cube root, and that's your cube root symbol. We already know that. So we're going to take a look at some of these examples. We're going to take the cube root of 512. So you look back, 512, that would be 8. 8 times 8 times 8 is 512. So the cube root of 512 is 8. E, the cube root of 1,000, that would be 10. F, the cube root of negative 27. So I'm looking at my negative perfect cube list. What number do you multiply by itself 3 times to get negative 27? That would be a negative 3. Oops, didn't mean to go that far. Sorry, guys. All right, and just look at your notes. What number times itself 3 times gives you a negative 125? Well, that would be a negative 5. Please, again, don't put plus or minus on these cube roots. 5 times 5 times 5 produces a positive 125, not a negative 125, okay? So don't put plus or minus. Your answer is either positive or negative on these cube roots. On square roots, they're both positive and negative. All right, so on H, we're going to take the cube root of 1, which is 1, and the cube root of 125, which is 5. So the cube root of 1 over 125 is 1/5. I, it's negative, so I want to keep it negative. And the cube root of 8 is 2. And the cube root of 729 is 9, I believe. Yep, 9. I started to say 7, but 7 is 343. Make sure you keep it negative. If you take the cube root of a positive, it's positive. If you take the cube root of a negative perfect cube, it's negative. Never both. So the cube root of a positive number is always positive. The cube root of a negative number is always negative, guys. All right, so for the remaining 12, what we're going to do is just solve the equations. So I'm going to undo each side by taking the cube root since it says cube. But you all, we should know what the cube root of x cubed is. If we know the square root of x squared is x, because the square undoes the square root and leaves us only with x, then this cube root will undo the 3, leaving us only with x. So the cube root of x cubed, guys, is x, just as the square root of x squared is x, okay? Because the cube root undoes the cube. So we're going to take the cube root, not the square root, of both sides. Do not put plus or minus because perfect cubes, their roots can only be positive or negative, not both. So the cube root of x cubed is x, and the cube root of 64 is 4. The cube root of x cubed is x, and the cube root of negative 64 is negative 4. I'm going to skip around, and then I'm going to allow you to pause the video and try the ones that I skipped. Okay, I'm going to go to something that has a fraction in it. 6. The cube root of x cubed is x, but the cube root of negative 8 over 27 is negative 2 over 3. It's because the cube root of 8 is 2, the cube root of 27 is 3, and it's negative. I'm going to try something that has a decimal. Try number 9. The cube root of x cubed is x. Now let's be careful on this one. The decimals normally confuse my students. But what number stands out? Like without the zeros, the number 27 should stand out. So that we know that's 3 times 3 times 3. Now I have 3 factors in my problem, okay? So I'm going to count my decimal places. 1, 2, 3, 4, 5, 6. Okay. So if I put a decimal in front of the 3 in each one of these, that's only one number there. That makes a total of 2. That makes a total of 3 decimal places. That's not going to work. So where would I put my decimal if I want a total of 6 decimal places in all? I'm not going to have to add, I'm going to have to add a 0. And in some cases, you might have to add 2 zeros. All right, 2 numbers there, another 2, another 2. That's 2, 4, 6. So I can tell you this is negative 300. Okay, I'll do one more of the decimals, okay? I'll do number 10. I didn't mean for that to go all the way across. The cube root of x cubed is x. And we're going to look for the cube root of, I'm going to be thinking about 1,728. So let's go up here. 1,728, that's going to be 12. Okay? So I already know that's like 12 times 12 times 12. But behind the decimal here, I have only 3 digits. So if I put the decimal in between the 1 and the 2, then I have 1, another 1, which makes a total of 3 digits behind the decimal. Just as there are 3 digits behind this decimal. So I know my answer has to be 1 2/10. You just keep trying your placement of your decimal until you end up with the same amount of digits behind your decimal as you do in the original problem. Like in this problem, there's 3 numbers behind the decimal. Are you going to pause the video and try the ones I did not do? All right, this is what you should have. So I'm going to go to number 3 and work number 3. The cube root of x cubed is x, and the cube root of negative 343 is negative 7. The cube root of x cubed is x, and the cube root of 1,000 is 10. 5, the cube root of x cubed is x, and the cube root of 64 is 4, and 125 is 5. So the cube root of 64 1/25 is 4/5. Keep in mind, a cube root can only be positive or negative, not both. The cube root of x cubed is x, and the cube root of negative 125 is negative 5. 8, the cube root of x cubed is x, and when I see 512, I think about 8 times 8 times 8, and there are 3 digits there, so 1, 2, 3, so 0.8. Here, the cube root of x cubed is x, and the cube root here is negative 4, and 216 is 6. Just leave it as so. You don't have to simplify. Here, the cube root of x cubed is x, and when I see 1,331, I think about 11. So I got 11 times 11 times 11. So where will I put my decimal in my 11? So I'm going to think about, I have 3 numbers here. So put a decimal in between the 2 ones. 1, 2, 3. So, but it's negative. So it's going to be negative 1 and 1/10. If you still have a question about one of these problems, just pause the video and raise your hand, and I'll come up to your desk and help you guys. We'll just talk through it one-on-one. All right, thank you. Just start on the classwork/homework that's posted on the classwork tab. Thank you.